All right, let's go over this problem. Skills practice, page 104, question B5. Let me read the directions. Determine the quotient of each expression. Quotient is division. Describe any restrictions for the variables and simplify the answer when possible. All right, the first thing we're going to do is we're going to see if we can do some division. And you can factor either before or after the division sign. I'm going to go ahead and factor before. So here I have a trinomial, and this trinomial, x squared plus 6x plus 8, it has three terms. This is an a, b, and c. Half of 2 is 1, so I can use my x box. This is a and c. This is your b value. If you forgot, ax squared plus bx plus c. A value is 1, so a times c, 1 times 8 is 8. My b value is 6. Notice these are just coefficients, the numbers in front of the variable. I need to think of two numbers whose product or multiply are 8, and those same two numbers, their sum, or when you add them together, they equal 6. And so I'm thinking of 4 and 2. So this will be x plus 4, x plus 2. All over 3x plus 2. And I said I would do division after I factor. Now this one, it just looks like they have a negative in common. So I'm going to pull out a negative 1 as its greatest common factor. Let's say that again. I'm going to pull out a negative 1 as its greatest common factor. So then I'm left with negative 1 times x is negative 1x, and negative 1 times positive 4 gives me a negative 4. So again, greatest common factor, to check your answer, you just multiply. Greatest common factor, to check that this is correct, you just distribute. All right, this next one's going to be a little bit more work. You'll notice in this problem here, because my a value is equal to 1, I only need to use the x. Here I have a trinomial, and the a value is greater than 1, so you're going to have to use both the x and the box. You must do it. It's not an option. All right, so in this problem, I have a times c, which is negative 6, and your b value is negative 1. Two numbers that multiply to be negative 6, I'm thinking, are 3 and 2. And when I add them together, it has to be a negative number, so that means this bigger number has to be negative. Negative 3 times 2 gives me negative 6, and negative 3 plus 2 gives me negative 1. I'm going to go ahead and highlight these numbers. So I have negative 3x, and this one equals 2x. These two are splitting the middle term, because if we add those together, you get negative 1x. All right, to finish this off, you have 3x squared, the a term, and all of it goes in the top left, always. Negative 2 always goes in the bottom right, and then we're just going to factor out. What do they have in common? The GCF here would be just an x. Here, this would be a 3x. Here, I'm not sure if it's going to be a positive 2 or negative 2. But if I go over here, they have a negative in common. Again, you can multiply to check your answer. 3x times x is 3x squared. 2 times x is 2x. And 3x times negative 1 is negative 3x. And 2 times negative 1 is negative 2. So in pink, this will become what's on the outside. Order doesn't matter. X minus 1 and 3x plus 2. The common mistake for students is to write x minus 3, x plus 2. So this is wrong. Let me write that. CM, common mistake. And here's the reason why I've seen a lot of students do this is if you just multiply these two right here, you'll know that's wrong. X times x is x squared. It's not 3x squared. So this is where the student misapplies the trick. Remember, a is greater than 1, so you have to do both the x and the box. All right, let's go ahead now and copy the first, x plus 4, x plus 2. And the bottom one is 3x plus 2. Now, again, at any time, you can always write parentheses around all of what's in the numerator denominator. Okay, now this division sign turns into multiplication, and I'm going to go ahead and flip the terms now. So in the pink, this will become on the numerator. And what was on the top, now it goes on the bottom. Just joined us, we're on Skills Practice page 104. Question B5. All we have to do is the quotient and then list any restrictions for the variables. All right, now you can do your counseling party. If you see anything on the same on the top and the bottom, I see 1x plus 4 and 1x plus 4. I see an 3x plus 2 on the bottom and 1 on the denominator. So when I simplify this, on the top there I have these two terms. And this one looks kind of weird. You have a negative 1 in the bottom. So if you divide anything by a negative number, I'll give you a quick example over here. This is kind of like our side work. 4 divided by negative 1. Negative 3 divided by negative 1. It just changes the math operation, yes? But if I took the same numbers, and let's just say I multiplied by negative 1, would I get the same answer? And I do. So dividing by negative 1, which we have, is the same thing as multiplying by negative 1. So to make the answer cleaner, that's what I'm trying to explain, is the negative 1, or you just can put just the opposite sign, or negative sign, x plus 2, x minus 1. So this is what it would be on simplifying. But now we have to list the restrictions. The question is, what are our restrictions? Original problem. Let's write that. To find restrictions, comma, look at the original problem. If you just joined us, we're on page 104 in your Skills Practice Packet, question B5. And I basically did all this work. And now we need to find the restrictions. So we have to look at the original problem. Let's see if I can get my yellow highlighter and make this super clear. The original problem is way up here in yellow. So this next step that I'm going to do is I'm going to look here and look at the denominator. So I have 3x plus 2. And the restrictions are that if I pick a number in here and I make this equal to 0, anything divided by 0 is undefined. That's bad. That's what the restrictions mean. So what we're doing here is I'm just taking this one and setting it not equal to 0. 3x squared minus x minus 2 is not equal to 0. Zoom in. 3x plus 2, you're going to subtract 2. That'll equal 0, and then you have negative 2. And then we just divide by 3, so x cannot be negative 2/3. There's one restriction. Let's do the other one, 3x squared minus x minus 2. Well, how would you solve for x here? You've already factored it. It's in pink. So I'm going to use this one now. X minus 1, 3x plus 2 is not equal to 0. Basically means now you can set each of those not equal to 0. And so here, to solve this one, we're just going to add 1. So x cannot be 1. This is my second restriction. This is the same one, so I'm not going to do the same problem. I already know what it is. X is not equal to negative 2/3. So it's the same. You don't need duplicates. So x cannot equal 1, negative 2/3. And I'm missing one. The answer has negative 4. And for division, let's add a second star. For division, restrictions are both at division and multiplication. Why did I say that? Because if you have one problem, let me go back up here for a second. If you go back up here, we did this restriction and this restriction. But if you change the division into multiplication, the problem looks like this. And then there, you actually have we already had 3x plus 2, but they're essentially the same problem, division and multiplication. So this would also be a restriction because the answer is negative 4. I'll show you in a second. But if you do negative 4 plus 4 is 0. 0 times negative 1 is 0. Anything divided by 0 is 0. So that is also a restriction. So let's finish that one right there. X plus 4 not equal to 0. Subtract 4. X is not equal to negative 4. So the three restrictions in our problem are 1, negative 2/3, and negative 4. You could distribute that using FOIL or the box method, but that's completely fine. So to review this problem, we were supposed to simplify in the list of restrictions. Division, you could factor either before or afterwards. I factored before, and then I did the division, which means you just take multiplication and then you flip it. Or you could have done the multiplication, flip it, then factor it, and then go back to get your restrictions, look at the original or after at the multiplication. I'm going to stop this video. I'm going to go ahead and post quote-unquote third period. We're going to go over 2 more problems. So just go back to my YouTube channel and then you'll see it and just click on it. So I'll go ahead and stop this one. See you guys.